All right, so in this video, we're going to be doing section 3.1. Let me move my camera a little bit better. Here we go. Section 3.1, expressions and equations. So I got a lot of definitions and terminology that I need to kind of go over with you right now, because you're going to hear me say this a lot, and you are going to hear these words a lot throughout the remaining of your school career. First off, expression and equations. A lot of people get this different. When it comes to mathematics, expressions and equations are literally two different things. First off, expressions is basically a variable or a combination of variables, numbers and symbols. So like the number 6, just by itself, nothing else, just the number 6 is an expression. 4r, this meaning 4 times r. This is an expression. Another expression, 4r plus 2s. This is an expression. 4r squared plus 2s plus 1. All of these are expressions, okay? Now, this is what an equation is. It is a statement that has two expressions, that two expressions are equal. So if we look at this, you've seen equations before in some form or fashion, but now we're explaining what this is. The number 6 by itself is an expression. The 4r by itself is an expression. But because we're setting them equal to one another, we create an equation. This expression is equal to this expression. The same thing here. I have an expression 4r plus 2s, and I have the expression 13, and since they are equal to one another, I have created an equation. All right, that's what it means. This is an expression. The whole thing is an equation. Now, you're going to hear me use those words a lot, so make sure you kind of understand what's going on. The next piece that we need to talk about is the word terms. This is a number, variable, product, or a quotient in an expression. Okay, so here's the thing. I have an expression, but this expression has terms. So I have a term here. I have a term of 4x. I have a term here, which in this case is going to be positive 2. And then I have a term here, which is going to be negative 3y. All of these are terms inside of this large expression. Why is this important? Because I'm going to be giving you expressions and equations that you have to solve and to simplify, which we'll go into a little bit more on that in just a second. All right, so why is this important? It's because in order to solve and simplify those things I'm going to give you, you have to do what's called combine like terms. Well, what's a like term? Well, it's terms that have the same variable raised to the same exponents. All right, so for instance, I have 4x and I have 16x. They look different. This is a 4, this is a 16, but they're like terms because they have both x's. Now, if I had wrote this 4x squared, this and this would be like terms because their x is raised to the same exponent, but this would not be a like term because it's raised to the second power. This is not the like term compared to these two, all right? Now, there's something I did not write in here, and it's the word coefficient. And so coefficient, I'm going to kind of put that here. And I'm sorry about that. So you're just going to kind of have to add a little note here. It's basically the number in front of a variable. All right, this is very important to know. So the coefficient is a number in front of the variable. So look at this. I have a term 4x. What's the coefficient? The coefficient is 4. It's in front of the variable. What's the coefficient of this? 16. It's in front of the variable. This one, the coefficient would be 4. This one would be negative 3. This one is not a coefficient because why? There's not a variable. All right, it's just the number 2. So the only time we call it a coefficient is if it's in front of a variable. All right, just like this. Up here, the coefficient for this one would be 4. The coefficient for this term would be 2. Coefficient for this is 4. Now, This is why I mentioned coefficients, because this is something that tricks a lot of people up. Again, this is one of those rules. You just got to know, I call it the hidden one. All right, it sounds kind of like a, I don't know, kind of sounds like a Asian karate movie. Wow, that sounds very stereotypical. Sorry about that, but it does kind of remind me of like one of those karate movies from back in the 1970s, The Hidden One. But what it is this: if you see a variable that does not have a coefficient, there's really a number 1 in front of it. For instance, if I gave you this, and let's just do it in a different color. If I gave you the number x, technically there's a 1 in front of that x. It's just a simple rule. It is a hidden 1. Even though there was nothing there to begin with, the coefficient is technically 1. All right? And this is also true if I have a negative x. Well, what does that mean? Well, technically, there's a 1 there. That's a negative 1x. This is very important that you remember this, because later on when you get into real, true algebra, this is a big deal. All right, so this is something that a lot of people ask me about. What does it mean to be simpliform? So let's explain this. It says an expression that has no like terms and no parentheses. So a good example of this would be this right here. Here's my expression, 4x plus 2 minus 3y. None of these have like terms because all of them are different variables. And there's no parentheses here. This is a simplified expression. And then distributive property. This is such a simple thing, but yet it will haunt you for a long time. I'm sorry for the squeaky chair, there is a written definition, mathematical definition that we use, but I'm not doing that here. I'm going to keep this as simple as possible and say this: when a group of terms is multiplied or divided by another term. For instance, look at what I've got here. I have x plus 5 and it's inside parentheses, and this has got a 2 on the outside. Well, when you see this, this is really saying 2 times this x plus 5. And so what we have to do is the distributive property. I'm going to take this 2 and I'm going to multiply it by this group. So I'm going to say 2 times x. Well, what's really in front of that x? Hey, it's a hidden 1 there. So what's 2 times 1? Well, it's 2. So 2 times 1x is 2x. 2 times 1x is 2x. Now I'm going to do the same thing. I'm going to multiply it on this part. 2 times a positive 5 gives me a positive 10. So I've used the distributive property. I simplified this expression so that it has what? No like terms and there are no parentheses. I just simplified this expression. Let's do the same thing on this one. I'm going to use the distributive property to simplify this expression to have no like terms and no parentheses. So I'm going to go 6 times 4x. Well, that's 24x. And then I'm going to go 6 times a plus 6 gives me plus 36. This is how the distributive property works. Now, right now, I've only shown you how distributive property works within multiplication. I'm not going to show you in division because right now that's not something I'm too concerned about. I'm more concerned about the multiplication side of things because you'll see that more often. Division would look more like this. 3x plus 6 all divided by 3. This would be distributive property using division. I'm going to be dividing this entire thing by 3. So 3x divide by 3, and I'm going to simplify that to get, oops, didn't mean to write that, gives me just 1x, and 6, positive 6 divided by 3 gives me a plus 2. So 1x plus 2, and because of that hidden 1 rule, we don't really need that 1. So this is simplified to this using distributive property, but you won't see that too much right now. All right, so I spent about 10 minutes, actually 9 minutes and 38 seconds describing all this. Let's go ahead and get to the point of everything and actually start working some problems. All right, so first off, it says identify, I don't want a pen, it says identify the terms and like terms in the expression. So what we need to do is we need to look through all like terms, and like terms are numbers that have the same variable raised to the same power. So the first ones are really easy. If you notice here, I have a 3x and another x over here. But this is the thing. Notice what I'm going to do is I'm actually going to put this. I'm actually including that minus. And there's a reason for that, because later on we're going to be combining like terms. So my like terms for this would be 3x and minus 7x. So I'm going to put a comma to keep them separate. But not only that, I also have some like terms here. I have a plus 4 and a minus 6. Well, Mr. Lewis, you said variables. Well, yeah, I did. But there's another little mathematical rule, and I don't want to say it confusing, but there's technically is an x here, but I'm not really wanting to do all that right now with you. But just know this. These are like terms because, hey, they don't have an x, right? It's just a plus 4 and a minus 6. So the like terms would be 4 and then a negative 6. All right? So here are my 4 terms. These two are alike. These two are alike. So let's do the same thing on the next one. Let's identify our terms. Well, I'm going to start here. I have a negative 9. This is not a like term with that one. This is not a like term with that one. But that positive 1 is. And this one's completely different. So I've used this one already, and I've used this one already. So now let's look at the next one. I have a positive 2.5y, so 2.5y, and then a minus 0.7y. Those are like terms. Well, this last one happens to be 6.4y squared, and it's a positive, so it's like that. And these are my 5 different terms. I had 1, 2, 3, 4, 5 terms. My like terms were negative 9 and 1. The other set was 2.5y and negative 0.7y. And the last term, which was by itself, is 6.4y squared. All right, so that was all it is. It's identifying the terms and identifying which one's like. Now we get into some more information here. Simplify the expression. So this is a word that question constantly comes up. What does it mean to simplify? It means to write this expression where there are no like terms. And the way we do that is we combine them. So let's look at my like terms. I have a 5a and a minus 2a. So literally what I'm going to do is I'm going to put those together just like they already are, and I'm going to have the plus 9 right here. And what's going to happen is this is literally going to subtract. And it's like saying I have 5 apples minus 2 apples. Well, what do I have? 3 apples plus 9. I have simplified this expression. Most of you are like, well, what's A? What's A? No, you're not trying to find A. A, if you were looking for A, this would not be an expression. This would have been an equation. All right, there's a big difference between expressions and equations. All right, so in this particular thing, we're simplifying the expression. I cannot do anything else to this because there are no more like terms and there are no parentheses. So let's look at the next one. Let's combine like terms. So my first term is the m, and then I'm going to find its like term. Well, its like term is a negative 4m. So I'm going to put that down. All right, so I've moved that. I've moved this. And now I have a minus 1/6. And then I have a plus 5/6. All right, so we have put our like terms together. M minus 4m. Well, what's that? Hey, this is going back where this right here doesn't have a number in front of it, so it's that hidden 1. So technically there's a 1 there. So 1m minus 4m. Wait a minute. Oh no, how's this going to happen? I've got this minus this. It wasn't like this one a while ago. It was nice and easy. 5 minus 2 equals 3. This is saying 1 minus 4. What do? Hey, I need to go back to those integer rules that we learned so long ago. And when I do, I find that 1 minus 4m is equal to negative 3m. Don't believe me? You can do some scratch work on the side, by just kind of putting it off to the side here. Hey, when I do subtraction, I need to do my keep, change. So 1 plus a negative 4, well, technically it's going to give me a negative number because this is the highest absolute value, and since they're different, I'm subtracting, which would give me 3, so negative 3m. Still don't believe me? You actually have access to a calculator now, do you not? Well, use your calculator. Find out what 1 minus 4 is. Well, let me grab my calculator and let's find out. So, whoops, there we go. Clear this all out. 1 minus 4. What do I get? Negative 3, so negative 3m. Now I have a negative 1/6 plus 5/6. Well, I already know the answer to this, but if we work this out, we can do it on a calculator, which I'm going to do it with you, just to kind of teach you how to use your calculator. I'm going to go negative 1 ABC 6, and I'm going to add 5 ABC 6. So this is saying negative 1/6 plus 5/6. Put it in the calculator, and I get 2/3. Is it a positive? Yes. So this would become 2/3. What happens if I didn't have a calculator? Well, you have to go back and do those original, going back to your rules that we've done with rational numbers. Hey, the common denominator is 6, so this would be negative 1 plus 5 over 6. Then we can simplify this to 4 over 6, and then it reduces down to 2/3, all right? So those rules about rational numbers are not leaving you, they're coming back to haunt you, and you're having to use them in the expressions and in the equations, all right? So we've simplified it. Now, let's try 5. So same thing, I'm going to combine my like terms. I have 2.3w, done that one, and I have a minus 3w, done that one. Then I have a minus 7, that one, plus 8.1. Notice what I've got. So now I'm just going to cheat a little bit. I have 2.3 minus 3, and what I get is a negative 0.7w. 2.3w minus 3w is going to give me negative 0.7w. All right, now the next piece, I'm going to go negative 7, and I'm going to add 8.1. And this is going to give me a plus 1.1. And I have simplified this expression. Nothing too complicated about that. All right, so the next one. Job again, simplify the expression. Now, I have a 7 parentheses d minus 1 plus 2. So your job right off the bat, you should be like bells ringing in your brain, is like, what do I do here? Well, the first thing you want to do is get rid of that parentheses, all right? Before you can do anything else, get rid of the parentheses. How do we do that? Using distributive property. So this 7 can be multiplied by this d. Well, what's in front of that d? An invisible 1. All right, so 7 times 1d is going to give me 7d. And then I'm going to take that 7 and multiply it by the negative 1. 7 times a negative 1 gives me negative 7 plus 2. All right, now my job is to combine like terms. 7d, there's nothing else in this expression there, so I can just write it down. And now I have negative 7 plus 2. Well, negative 7 plus 2 is negative 5. I have simplified this expression. Let's go to the next one. A little bit more complicated, but same principle. I need to get rid of the parentheses using distributive property. So I'm going to write this 13g down, and then I'm going to go 2 plus 4k. Well, positive 2 times 4k gives me plus 8k. All right, plus 2 times that gives me that. So now I'm going to do the same thing with this. Well, this one right here says a minus g. Well, what's technically there? It's the invisible 1, that hidden 1. So positive 2 times a negative 1 gives me negative 2g. Now, my job is to start combining like terms. I have a 13g, and I've done that one, and I'm going to combine that with that minus 2g. So I've moved that one. And then I have a plus 8k, and it's by itself. There's nothing else I can do with it. Well, 13g minus 2g, well, 13 minus 2 is 11g plus 8k. K. I have simplified it. There's nothing more I can do with it. Their variables are different, and there are no parentheses. 8, same concept. I need to get rid of those parentheses, so I'm going to use the distributive property. Now, I need to do that first. So 20 times this gives me 20p, and 20 times 2 gives me 40. Why 20p? Because of the hidden one. Don't forget the hidden one. Now I need to do the next piece. I have a plus 16 times a negative 3. Well, let's just do that. 16 times negative 3 gives me a negative 48. So that becomes negative 48. Then I have a positive 16 times a negative 1p. Don't forget the hidden 1. And that's going to give me a minus 16p. Let's get our like terms together. 20p, write that one down. Then minus 16p, wrote that down. Plus 40, wrote that one down. Minus 48. Now let's look at our like terms. 20p minus 16p gives me 4p. 40 minus 48 is going to give me negative 8. I have simplified this expression. It has no like terms and all the parentheses are gone. Number 9, write an expression in simplest form that represents the cost for shampooing and cutting women's hair and men's hair. All right, so this one's kind of confusing at first. So it's looking this, the cost for shampooing and cutting women's hair and men's hair. All right, so if we look at it, all right, I had to stop and think there. So if you're wanting to know how much it's going to cost for one woman to get her haircut and shampoo, how much would it cost for one woman to get it? Well, a cut's $15 and a shampoo is $5. So to get both, it's going to cost her $20. But we don't know how many women are doing it. So we're going to put W there. That W represents women. How many women got their hair cut and shampooed? We don't know. And the same concept happens with men. But for a man to get his hair cut and shampooed, it's going to be $9. And we're going to put M for men. All right? Now, with that being said, you have $20 per woman and $9 per man. And we want to know, it says write an expression in simplest form that represents the cost for both of them. So, there we go. We would put it both. It's both of them added together. However many women there were and however many men there were, this is the expression that we would get. And if we know how many men, let's say for instance, I am a hairdresser and I know how many women I served that day and I know how many men I served that day and they all of them got the exact same cut and the exact same shampoo, I can find out how much money I made. All right, that's it for this video. You know how to find me. This is one of those basic things that you need to know. We're going to spend some time on this with expressions and equalities and equations, all those wonderful things in this chapter. So you know how to find me. Please find me when you get stuck on something. You need to. Otherwise, you're just going to get farther and farther behind. I will see you in the next video. Bye-bye.